Well, hello, Matt. Welcome back, my friend.
Hi, yeah, good to be back.
So, what's the weather like out there?
We actually just got our first nice day, over 60. It's been rainy, cold. We've had a couple of frosts. We still got one more 38 degree on the forecast, but as soon as that day goes by, I think next weekend I'm gonna start some planting anyway.
Nice, nice. So, I'm sure if you tried to pull samples from outside, you wouldn't probably give very much with this cold
Mm,
weather.
Yeah, mostly just bacteria. Every found a bunch of dead nematodes and stuff like that. A couple of protozoa like flagellates, but that's about all I'm seeing with but just fungi and bacteria.
Gotcha, gotcha. Well, looking forward to another tour of the microscopic world today.
Yeah.
If you want to start firing up slides, and let's just roll up our
Yeah,
sleeves.
we got a slide going. We got the a new LW scientific microscope, so a lot better quality than our last scope. Right now we got a compost under there at 100x,
Okay.
and seeing some nice strands of fungi in there.
Nice.
We also got a digital capture card, so I should be able to just do some pretty good digital magnification. So now we're in at 4x digital, and since we're capturing at 4K, this is just 100x, so we're already looking at like as good as quality as most 400x. We can almost see the bacteria down there just with the 100x objective. So yep, really liking the LW Scientific i4.
So how far can you go down? So I'm just beyond what we call an oil.
I just have the most. We're on the 10x objective, so we can go all the way up to the 60x objective. So that would be 600x total magnification. So that's without digital zoom, but it's cool how good of an image you can get with just the 4K resolution and just zooming in with digitally. It makes it a lot easier to work with instead of having to switch objectives. Now I could just take quick looks at things digitally and see it with actually more focal depth, because the lower magnification you are, you get a little bit more focal range, I should say. So a little bit more of what you're looking at is in focus at one time.
So is that digital piece of it, will it magnify on 600 as well?
Yep. Oh, so when we go in, we could even go in, so we can really test the limits of the optical, and then what we have for digital resolution. So here we'll go in. So I just switched over to 400.
Yep.
Let's get a little bit more focus, a little bit more light.
Yeah, I'm wondering if you can actually get the nucleus moving around inside the fungal hyphae.
Yeah, sometimes you can see a little bit in there. You still don't get any more resolution than your typical oil 1000x or other 600x. But so now we're at pure 4K 400x. So if we double it, and then even all the way in, now it's tough to get focus, but
Oh, look at those.
We start being able to make out
the septies
up inside the fungi. We'll go down to the.
I mean, you almost had it right there.
Yeah.
Sorry about that.
A couple of different. Yeah, actually, we got to go down to like right about. Yeah. Still get a little bit of blurring.
Yeah, you can see them. That's fantastic, dude.
But yeah, and we got the most shade right now. And open that up a little bit, but yeah, we can see. Whoops. This zoomed in. It's tough to move the slide around. It's very delicate. But yeah, now we can see all the bacteria in this compost. It's tough to get a good focus on them. But yeah, there's some quick moving ones. Maybe right about, yeah, right about there. Yeah, a lot of basilisk. Got some rods, some round ones in there.
Very cool, dude.
Yeah, we'll go out to. So there's our 400x look from with no digital magnification. So now we can scan around like this. Yeah, I was seeing right over here. I took a quick scan across, and I saw some really cool with the polarized lenses I have in there. When you find a mineral, where were they? Yeah, there's a kind of cool looking one, but before I saw other, but yeah, good amount of fungal hyphae in there.
Yeah, it certainly is.
But where was I on the slide? I was scanning around at 100x, trying to see where I could find one of those. Oh yeah, here's a pretty cool one.
Yeah.
So it's wild the different, yeah, like right about there, the cool light that you get with the two polarizers, and then watch what happens. This is really weird. So I'm just gonna twist the lower one and see as the color changes. And now if I get them just lined up, it'll go totally dark. Where is it? Come on, somewhere. Oh, it was going totally dark.
That's all right. You still got time to play with it.
The light down a little bit. There was some. I thought there was some spot. Maybe I gotta flip it over. Maybe it was when it was like this. Oh yeah, there we are.
Nice.
So now, when you get it right there, totally dark, it's pretty wild what minerals end up looking like.
Yeah, I'm almost thinking it might be like quartz because of the way you're getting that
yeah, and they glow, and
colors.
It's almost like dark field with just two polarizers.
Yep.
You know, you twist it, comes into light. Twist it right there. They line up in the right way. It blocks the wavelength. Yeah, you can almost see some bacteria on that mineral.
Very cool.
Extracting nutrients.
There you go.
Yeah.
Right there, dude. That is friggin' awesome. Amazing. Now, is that considered epiphorescent or is this something different?
No, yeah. This is just the polarizers. I just figured out this by accident. So, I'll twist it back to normal. We get a whole bunch of different bands of color with the polarizer. And then when I put on epi, let's go back to regular. But then when I turn on the epi light, we get this. So now we actually got to turn the other light way down, and we'll turn up our ISO. And actually, if you turn this light completely off, now we're seeing just the bounce back light of the epifluorescence.
Wow.
And especially because it's a compost, there's a lot of, it's a Johnson Sioux compost, so it's about a year old. We're getting a lot of glow from the actual water itself right now. So that's kind of a hint that there's a lot of minerals in there, or a lot of nutrients, or nitrogen and phosphorus anyway.
Now, have you been able to identify mycorrhizae?
Yeah. So I got a couple of roots. That's what we're gonna what I want to check out next. We can actually bounce out to 100 here. We can kind of get a better look. We might even be able to find some mycorrhizae in the compost. Like actually right here. That actually looks like it may be a little piece of root.
Yeah, root hair.
Yeah, I actually think.
And those two little infection sites.
Yeah, like right here, and you kind of see that could be the cell walls, but like right over here, it looked more like a fungal strand. Kind of in the top part of it. Oh yeah, I don't think could you guys see my mouse if I move it over here?
Now we can.
Now
Yeah.
you can.
Yep.
So yeah, we got the infection spots here and here. This little curve, that kind of looks like fungi.
Yep.
This, and this line here. That's actually, we could probably go in. Let's switch to the 400X and let's look at that a little bit closer.
So what those could be as well as endophytic fungi.
Yeah. So pretty much that's all we do see those kind of glowing spots. So it's likely that they're doing something with phosphorus.
Yep.
Yeah. Let's take a close look and make sure. Yeah, sometimes. No. Yeah, that doesn't really matter. So let's go in a little bit closer here. That might be a little too close.
Oh man, that's badass, dude.
Still a little foggy with the water. We'll get a better look of some fresh fruits on there without water that we'll be able to see through a little bit better. Still haven't figured out if the best way to get it is to put a lot of water on the slide with the root or just the root on there dry. But we can try a little bit of both.
Yeah, absolutely. The only thing that I would say is if the root was dry, you're probably going to want to try to press it a little bit so that you don't.
I was thinking just putting a cover slip on it just to protect the objectives because I don't want to bump the objective into it and get all dirty. That's a pain in the butt.
Yep, and you might want to just try to press it gently. Don't snap the slide, but just so the slide is more level.
Yeah. Wow, whatever that is has some phosphorus in it. That's glowing bright.
Yeah, it is.
Organic matter.
And was this Johnson Sue? Was it manure and chips, or was it a regular?
Oh no, pretty much all. It's a mix of like I have a little wood chipper, so I grind my chips up pretty fine. And just use stuff from around the property. Plus, I'll mix in leaves and then grass trimmings, and then other than that, I'll use stuff from the garden and food waste.
Nice.
And that's pretty much all I put in it. So this is pretty much a year old. Usually, I just kind of go in and I take the bottom of the stack, and anything that doesn't go through the sifter ends up just going right back into the pile. And then I just keep on piling it up, adding it down, and take off what's in the bottom.
Are you adding moisture to it or just letting it naturally accumulate?
Yeah, occasionally. I need to be a little bit better about it. I was actually noticing when I took this sample that despite all the rain, I still need, because it's in a little, one of those black, enclosures with a whole bunch of holes in the side. Look at this that we got glowing. But I was actually noticing that the bottom was drier than I thought it would be despite all the rain. So this almost looks like a sporulating.
Is there a thread coming off of it? Yeah.
Yeah, just how this is here. Yep. And that's glowing and phosphorizing under this very specific wavelength.
So as you travel down to that, what looks like a nucleus.
Yeah, there's something.
If you keep going down further, it looks like you could find the tip of it or the end of it.
Yeah, there is that just might be a piece of something on there. Yeah, and then the tip's right there. So
this is a really cool phenomenon that I love to talk about is that imagine the spore, right? It's, in a three-dimensional matrix. It doesn't know what's up or what's down, what's north or west or east or south. It knows nothing about its environment, but yet it has the ability to quorum sense, whether it's chemo, quorum, or perhaps electrical or magnetic. We really don't know. But it knows where to send out its smooth. So its smooth, it's when you get the actual spores is, whether it's looks like a football or a true circle, it will send out a little foot and that foot will start to grow. This is a perfect example of it. And it will chase toward the root. So, if you think about the phenomenon of nature, knowing how to find a root in a three-dimensional environment where you don't know where to go, it's pretty phenomenal. I mean,
Yeah.
nature is like incredibly beautiful when you start to really look at, how it's functioning.
Mhm.
So I'm glad you found this, because this is a really cool, unique way to talk about schmooze and how they find the root.
Yeah, it's pretty interesting looking one. Let's look at right at the root tip here. See all sorts of stuff. Might even be some bacteria.
Well, there's a thing called
Bacteria here.
it's like a biosymbiosis where the actual bacteria can group up on the very tip of the what we call the mycorrhizae spore, and chase it. So they're actually there to kind of like protect the tip. If you may, roots do it. We know this through border cells. And when the root tip finds an anaerobic pocket, it actually like shoots out all these border cells to protect it from getting converted into alcohol, burned off. So those border cells are like the first defense, like sending out the Marines to kind of push back whatever's coming toward them or whatever it's going toward, giving it a second chance to turn and go the other direction so that it doesn't vaporize or get consumed. So I'm probably thinking that's a similar function right there that with the schmoo, that it's attracting the bacteria to protect it if it does run into some kind of predator.
Yeah, I'm seeing it. Another one of those round looking, like the similar spore that we just saw, but it's a little darker, not as clear.
And it doesn't look like it has a schmoo, does it?
Yeah. And then another one right here in the middle.
Yeah, why don't you zoom in on it?
Yeah. Do a quick little 4X on that.
So cool, dude.
Do a little focus. Yeah, it's looking more like and considering the size, I don't think it's an amoeba. All crusted up. Looks more like a spore.
Yeah, hit the epiphorescent and see if it glows.
Yeah. Throw that on. Turn this light down. No, not glowing much. We see some glow up over here, but no glow in that guy. But yeah, it's cool how quick you could just check. I love that about this scope. Like, and if you see
another
strand that could be microplastics, you can just check. That'll go bright red and orange.
It might be. You ever seen The Spark of Life?
I don't think so.
So when they've been able to film this now a number of times, when the sperm comes in contact with the egg, the sperm enters, and then there's a flash, very brief flash of light when the cells merge, and they call that the spark of life. So I'm thinking maybe that the spores actually have a similar process where when they do actually get, whether it's chemical, whether it's electrical or magnetical, but they get that signal to schmoo, maybe that's when the epiphorescence or when the phosphorus starts to light up and help create the energy that it needs to grow out toward that root. Again, hypothesis, but if you start looking at nature and thinking that usually things repeat itself in nature, whether it's the way a tree grows or whether the way rocks are formed, there's a lot of similarities and repetitive processes in nature.
Oh, I found a ciliate.
Fast mover?
Yep.
Oh yeah, there you go.
There in the middle, cruising around.
Yeah, he's not flying too fast. He might actually might be a facultative.
Actually, he's not moving right now. He's probably going closer.
There you go.
Whoa. Yeah,
Go figure, right?
back to 2x. Got a good little glimpse of him though.
You see how he's spun too?
Yeah. Oh, there it is.
Yeah, see how he's spinning?
Mm.
There's like, you've seen the race cars, right? The true ciliates that are perfectly oval and they just fly. Where this guy's bumbling around a little bit more.
This guy's a little rounder.
Yeah, he's odd shape.
Mm.
I typically see these in areas that have been exposed to some kind of anaerobic conditions, whether they're full on anaerobe or whether they're reduced oxygen. You typically see a lot of those. And there's another one that zipped by.
Yeah.
So I would tend to categorize that as a beneficial and not as a true anaerobe.
Yeah, I'm only seeing a couple of them if we see it. Usually in when you're brewing compost or something, you'll see them multiply up to the point where there'll be, maybe 50 or so on the slide. And then if you let it sit for a while and scope what's left in the bucket after you use it, like a week later, you'll see hundreds and hundreds of them running around all over the place.
Yep.
I wanted to see if, because I saw another, that one looks like it's glowing a little bit more. Turn the ISO up a little bit. Oh, yeah.
Oh, there you go.
Yeah, right in the middle, we saw another one of those round spores looking, but trying to get a good focus on it. But yeah, this one, it's interesting how, that one's definitely glowing more than the other.
Yeah, but not nearly as bright as the one that had smooth.
But yeah, not nearly as bright as, other stuff will be. We'll go back. Oh, right about there. Turn that light off. Yeah, let's see. We're at 100x, so we can scope around. How are we doing for time? Yeah, we still got enough time to look around a little bit more. But yeah, definitely happy with the amount of fungi that I'm seeing in this compost.
Yeah, fantastic work.
Yeah, definitely. It's gonna be ready to go here for spring. Anyway, at least a little bit of it. That's just kind of a weird looking little fragment. Let's see if so. One thing we could do with the epi. And no, it's not really glowing. For his microplastic, it'll be glowing brighter than this aggregate over here. And then we'd see some orange or some red. So just kind of a weird little piece of something.
Yeah, or a piece of organic matter.
Yeah, could be a little piece of lignin or.
Yeah, they usually spiral out, but or that's the cellulose. One of them spirals, and the other one does that.
Yeah, the cellulose is the spirally one, I know. All right, where are we on the slide? I think we got to go straight up to the middle here. I don't think we've checked out that area yet. Yeah. Whole bunch of fungi. Oh, little testate amoeba.
Nice.
Right there in the middle.
Yeah,
go in to 4x. Very small one.
Yeah,
right there in the middle.
Got a full belly.
Yeah, it's got some
clearly define the oreganellos.
Yep. But yeah, it's really small. So now we're at 100x, so we can't even see it.
That's super cool, my friend.
Let's see. We can just take a scan up over here. So there's some big fungal hyphae.
You want to zoom in on that?
Yeah.
Let's see if we can find the nucleus.
Go in. Yeah, let's go into 400. I think I got to just go over here. There's that. Turn up the plate a bit. Oh, I think we got a flagellate.
Yep, something bobbling around.
Yeah. And he's swimming by a spore right now.
Yep.
Single flagella protozoa, anyway. All right, let's get the focus in on this. Wow. It's weird when you see these fungal hyphae that look so weird like this sometimes. It's like maybe they're just old, breaking down, but they got all this color. Oh, right there.
That actually may be a root tip.
Yeah, it could possibly. I see a lot of the
See this-
little things hanging off.
Yeah,
But that could be other fungi.
Now, have you ever witnessed when the fungal hyphae comes under attack by anaerobic bacteria and they just start mining it from the outside?
Yeah, I've definitely seen some just bacteria covering a fungal hyphae sometimes.
Yeah, that's what they're doing, is they're mining.
Let's turn this completely off real quick. And we got to put our ISO back up. We don't need to quite go that high. And what's our speed? Yeah, that'll about do. It's hard to get a real good look. But definitely glowing a little bit, this hyphae. But yeah, not as much as, so here's a mineral with some phosphorus in it or something that's glowing. But you can see the fungal hyphae for going right into it right there.
Interesting.
And mining it. Or if it is a root, maybe mining it. Yeah. Switch back out. I'm going to turn our light back on. Turn this bit back up. So yeah, there we see it on the bright field. You can see the fungal hyphae. See the mineral aggregate.
Yep.
Yeah, I almost see some other little bit of fungal hyphae there. But we can turn our ISO back down so we lose some noise. Oh, come on. Nope, go to where I want you to be. Yeah, that'll do. More light.
Wow, too cool.
Yeah, we can really, the organic, I can look at just the organic matter breaking down for a while. Always looks slightly different and really cool.
Yep.
With the fungal hyphae coming in and out of it.
Mining those nutrients.
Yep. And yeah, so now we're at stock 400X. I was happy. There was a.
I'd love you to come back on at the beginning of summer, when you can take some stream samples and some samples out of the garden.
Yeah, we'd see a whole lot of microbes, especially in the stream samples.
And with all these tricks and toys that you have attached to that, would be just a blast to really see, who's emitting light.
Yeah, there's a whole bunch of tiny bacteria in there. And I'll zoom in on this weird little round thing here.
Yeah, it's like a spore. Could be a flagellate spore, because they're really tiny. Clearly a lot bigger than the bacteria.
Yeah, but got plenty of bacteria in there.
Yeah,
a whole bunch of little things bumbling about, and some quick ones. Or it might be a really small flagellate, but
flagellates are tiny, dude. They're so small. They're just maybe one or two sizes bigger than a bacteria.
And then it's cool seeing the little rods that are super tiny. Every once in a while, I can catch them, and they'll have a single little cilia on there, and they can be pretty quick. Just tiny little basilisk.
Ooh, is that a nematode?
Yeah, used to be a nematode by the looks of it, just because his whole body is filled with bacteria, breaking it down by the looks of it. Yeah, probably didn't make it through winter.
No. Food for somebody else.
Yep, it's probably not much left for identifiable mouth parts here.
No. Clearly they've been eating that.
Yeah, no, but kind of looks like it's got that bacterial feeder whiskers, but really can't tell.
You ever seen the one with the big kissy lips on them?
Yeah, one of and then I saw a crazy one that one of the Matt Powers students posted in our group that had like trap jaws. He had kind of kissy lips and trap jaws, like two spikes that came in like this. I was like, never seen one with that. Looked like, like like a, pig hordes or walrus hordes or, something out of sci-fi.
So
Might have been some kind of omnivore or predator.
Did they tell you where they collected that or found that and what type of material?
I'd have to look at it, but I think it was compost. Yeah, we see some nice clear fungal septies there. Go in a little bit closer.
Ooh, there's the nucleus, I think. The white dot in the middle. Sometimes I'll see like like a whole bunch of them gathered together in one segment or in one in between two septi and a hyphae.
Yeah, like
so it's
this dot right up here.
Yep. Is that inside or is it outside? It's hard to tell.
That's inside. Is where. Yeah, right there. Looks to be about the middle.
Yeah. He's about the size of a bacteria, which makes sense.
Yeah. What do we got? Should we what? Oh, let's actually look at this end right here.
Oh, looks like it's clubbing out.
Yeah, it just kind of look like, well, maybe just branching. Yeah, just kind of branching out. Wanted to take a quick peek, see if it was a club or not. Change our focus a little bit.
Have you ever seen like the cytoplasm oozing out of one of the ends and then all like a bacterial swarm around it?
Not really. I'm kind of looking for it.
I've seen that a couple of times. It's really cool. And I don't know whether it's like because I broke it when I was shaking the vial that opened up and allowed that cytoplasm to leak out. But watching the bacterials, like it's like a feeding frenzy. They circle all the way around it, and then they're just buzzing around like crazy.
Wow. Here we got a really large fungal hyphae. That's a nice looking strand. Yeah. Keeps going all the way over into here.
To the aggregate.
Into the aggregate. Yep. Forming that soil sponge.
There you go.
Yep. Oh, whoa, what's this? That might be the same. Yeah, same shape. Might be the same one we saw before.
Hanging on to that organic.
Doing his dance.
Yep. Now, I'm sure you've seen flagellates dragging along their backpack of lunch, right?
Yeah.
That's so cool when they do that. So one of the flagellum, they grab a piece of organic matter, and the other one they use to propel themselves.
Yeah.
They're bringing lunch with them wherever they go. Yeah, that's interesting. So maybe a microorthopod egg.
No, it almost looks like there's a nematode just wrapped perfectly around this. You can go in a little closer. Dead nematode, that is.
It's something.
So it looks like just a typical little aggregate in the middle. I don't know what would wrap around it like that.
It could also be like an endoskeleton on a microorganism.
Yeah. Or an amoeba that tried to eat a whole aggregate.
And blew up.
Yeah. Didn't quite get there. Anyway, I was watching I was liking what you were saying on just water systems on one. I forget what guest you're with, but yeah, how we're really good at channeling water, but not so good at holding it on the land. But we're getting better.
Yeah.
And
there's so much to water.
Yeah.
I don't know. Did you listen to the one with Gerald Pollack? We were talking about.
The fourth phase water and all that.
Yeah. He's some of his new work. He's hypothesizing that the key to preventing cancer and getting a healthier cell is to get a higher millivolts, which would be more like an alkaline condition than an acid condition. In intercellular, so within the cell.
Yeah.
No, I love that guy. He's a blast to have a podcast.
Yeah. So let's see. Other than that, I think we pretty much scanned all around this compost sample.
All right, you want to load up another one? We got about 22 minutes left.
Yeah. Actually got a couple of root samples here that I grabbed.
Nice.
Let's
What'd you pull them off of?
move that. One's cannabis, and then the other is Simpson lettuce.
Oh, okay.
Yeah. Getting a little wilted. What?
There you go. Snap.
Still nice and crunchy. So let's see. Oh no, did I just lose one of the roots? When I showed the lettuce, I might have. Well, we'll start with the lettuce here.
There you go. Got stuck on the
find it. Oh no. Sloppy scientist. But let's see.
The farmer, Cheryl, I don't believe we can get you discounts. Unfortunately, I think you have to become like a distributor or something. I know Elaine was able to do that through her work, but she was buying a lot of microscopes for people, especially back in the day.
Now, the one thing Matt Powers, and Matt can talk about this, is if you're one of his members, part of his classes, you do get a discount on this microscope and setup. I think Matt was saying it's 40%. So you might want to look at that, Cheryl.
I think it's 37% right now for the current class.
Oh, nice.
All right. Let's see. Where is this root? Aha. There we go. What's our magnification? Yeah, we can start looking at it. Let's see if we can get a good focus. So this is our lettuce root. And oh, we might see some stuff in there. This is interesting.
Now, is it grown in hydroponically or in?
Oh no, actually a horizontal
Okay.
6x3 bed that I built pretty much all off your system.
Nice.
Did a bunch of rocks and sand and a bunch of sand from a stream by the wetlands.
Nice.
So let's see. So we're seeing some glow in this root, that's for sure.
Mm-hmm.
Where's my settings here? We want to go. Yeah, we can go down on shutter speed a little bit, up on ISO a little bit. Yeah, I think that's plenty. All right. Yeah.
So, Matt, how often do you offering these courses?
Mm-hmm. Oh, well, it's the Matt Powers course, and he has one every what does he do? He does usually like 2 or 3 a year. So they're pretty frequent. I know the regenerative soil one is just about finished up and the microscopy just started. So he'll probably do one of each later on this year. Let's see. Let's get right into that glowing area in the middle. Roots do look really cool. Not seeing anything.
No, I'm not seeing the infection like we saw in that other one.
Yeah.
Because the infection site would be, well, it would be close to the surface, whether it's on the sides or the top.
We're seeing a little bit of glow right there in the top. Oh. Might be some signs, but trying to see if there's any hyphae in there. Just moving up the root. But it does look like there's some things, like right here on the outside of the root.
That dark spot?
Yeah, but this does kind of then goes up to this dark spot. But that could just be, fungi on the outside of the root.
Or an endophyte.
Yeah, an endophyte growing. Oh, yeah, right here. Let me see if I'll zoom in a little bit closer. That definitely looks like it's something inside. Let me go up. Oh, no, too much. Right there. All right, so now if I go in. Oh, maybe too close. Yeah. Right here.
Mm-hmm.
Let me adjust the focus a little bit. No,
it's definitely something internally in that root.
Yeah. So you can see it. Oops. Just whack the camera. I lost my focus point. Yep, you can kind of follow. We're following that up. Oh yeah, and right here. That's the kind of bright glowing green that we want to see.
Mm-hmm.
In very specific spots. Oh, we're very bright up here. Kind of go through.
Really cool, dude. You just see like that right on the outside edge of the root.
Yeah, right on the outside edge. It's pretty wild. Oh yeah, and you can see, there's definitely even a little root hair or something. Some of these might be root hairs that are squished down. We got something sticking out over here on the right side. It's very small. Yeah, those might just be most likely just little tiny root hairs. Get that focused into the middle of it here. Oh, see some more.
Now, guys, what does this indicate?
Basically, the main indicator is anytime you get this really bright green glow, it's phosphorizing because this light is so narrow that it only makes, anything that phosphorizes, mainly phosphorus, glow really bright green. And so it's a perfect way to test to say, hey, is my mycorrhiza working? Do I see my plants glowing with endophytic fungi or not?
And remember, there's many different phases of phosphorus.
Yeah.
And you get into phosphines and all kinds of crazy shit. Phosphases.
Mm-hmm.
Now, also, guys, just to let you know, this is lettuce Russos brassica. You don't normally, or we didn't normally think that they did this, but we're now realizing that this bacteria does colonize.
Well, again, the plants have these processes, whether they're mycorrhizae associated or not. They still need phosphorus, so it's probably a bacterial species that's doing the work for them.
Trying to find the other root I dropped. It was a pretty big root.
Now you're just rooting around, Matt.
No, I'm just rooting around, picking roots off my floor, All right.
Maybe we'll get a couple dust mites too.
Yeah, those will always be cool to look at.
Those fuckers are scary looking when you really zoom in on them.
Yeah, it's still looking somewhat intact. Yeah, let me grab a new slide real quick, and we'll throw that one on there because this one I saw some really nice endophytic fungi on. Let's see if we can just do a quick comparison. Let's see. Try to break this apart as delicately as possible. Yeah, we got 2 strands right there. All right, we got 2 nice little pieces. Get the other side out of the way. Yeah, we'll just put this one right under the scope here. And let's actually go over. We'll start at 100 so we can find it nice and easily. And there it is. All right. So, yep. So now we're on to a little bit more advanced of a plant. And, oh, yeah.
Look at all that.
Now we're seeing... And let's see. Yeah, we should probably just go right back into 400. Don't hit that root. So now we can see what
the highways.
Yeah. The highways of all these
this
bright
is
glowing strands of.
And this is the cannabis plant, correct?
Yeah, and this is cannabis. That we inoculated the seeds at start.
What product did you use?
Root wise and also mycogenesis from AEA.
Okay.
Advancing Eco Agriculture. Yeah, without the cover, actually, we get a little bit more focus at 100x. We go to 100, and we can actually just use our digital zoom. Oh, actually, we were digital zoomed a little bit. Yep, and now we can really start seeing those. All the veins
So cool, dude.
glowing bright.
Let's see if you can find an infection site.
Yeah, I'm trying to find a bright. Maybe really bright right over here. That's pretty bright. But we could probably find something better. Oh, yeah. Yeah, I think right in here, this spot,
Mm-hmm.
and right in there, all sort of look like
And again,
infection spots.
yeah, it's difficult to, or I should remind everybody, this is a round surface. So if you're seeing them in the center, that's because it's the top of the root. Like there's a beautiful little dot.
Yeah.
And then also that heavily lit on the right side of the screen.
Mm. Focus on that right side.
But again, just seeing those internal networks is so cool.
Yeah.
It's like, fiber optics, man.
So much going on. Let's look at this little root hair over here real quick. Come on. Yeah, I mean, that's got a little bit of glow.
Yeah, a little
Sucking
bit.
up nutrients. There we go. There's the green color that we really want to see.
And it's almost like they're outlining the cells. I know they're not, but they're blocks. But
yeah, but especially is when you get this nice green that's not so yellowish. That's what we want to see. That's pretty cool. Oh, some more bright. That's a really nice bright looking green spot right there.
And it looks like there's a dot there, upper about 9, 10 o'clock or 11.
Yeah, also
Yep.
right over here and right there. Yeah, free phosphorus.
Oh, bam.
Oh, even more glow. Just keeps going.
Mm-hmm.
Keeps on getting brighter.
You think you're moving up the root to a fatter part of it?
Yes, I broke it. I pulled it off like this and I laid it on the slide so the thinner end would be going the opposite way that I'm moving right now.
Which makes a lot of sense.
Yeah, so we're getting to the older part of the root.
Yeah, the meat and potatoes.
Wow. Actually, probably could. Yeah, I just lowered the ISO a little bit to try to get a little less noise. What's our speed? Yeah, we're good enough for speed. Yeah. Oh, focus in on here. Oh, yeah, now we're seeing
Entire networks.
Larger. Right there, you can tell that's definitely fungal hyphae, and it's not just the edge of the cell walls. These lines right here.
Mm-hmm.
So that's probably the older network. Yep, another line coming right here.
Or an endophytic.
Yep, or just some other endophytic fungi doing other functions other than AMF and phosphorizing. Let's get focus on this. Yep. More.
Okay, guys.
Yeah, a whole bunch right over here on the.
Oh, it's okay.
On this edge.
Yep.
Yep. Yeah, we can almost see right here. I think as it's, you got an inoculation point and it looks like it's kind of leaving. Going out into the soil.
Yep.
We get a little bit better look at that, but
Like, guys, for a farmer, like, you could do this out in the field pretty much if you set it up right. What's this, the benefit
yeah.
for the farmer knowing
The
this?
scope roots look so
Well,
much different than it did with the old scope.
I think what's important to understand, Ken, is that you are missing 50% of your potential nutrient harvesting if you do not have mycorrhizae colonization. You have 50%. You're 50% of your F2B, and you're losing 50% of the potential nutrients that could be mined, as well as cross communications. Because remember, these mycorrhizas are connecting to multiple plants together, Cheeto player, and they're transferring information as well as nutrients, as well as bacteria, and as well as protein. So there's like a whole, like, you're missing your highway. You're not being able to exchange information, nutrients, and biology. So it's important to have the mycorrhizae. Now, if you get into seasonal crops or 90-day crops, then it's less important, because by the time that mycorrhizae has its full established system from mineral to plant, usually takes about 90 days. So it's more important for orchards, for longer term, like border plants, shrubs, annuals, or perennials, excuse me. Those are where it's really important to understand it. And you can send samples to Matt. I'm sure he would be willing to charge you a fair fee to tell you what percentage you have. Or there's guys like Efren out in Oregon, Myco Roots, who will do the testing for you. Oh, that's some cool stuff, dude, right there.
Yep. Yeah, I'm always happy to look at stuff, and I like just documenting the video. I'm not about the numbers. I'm more of a ratio guy, and mainly, I think the best data that you can have is just video data of a nice scan, so you can go back and actually look at it, and do a side by side with the digital, and you might see something that you would have not seen before when you do that too. But yeah, you can see what it's like looking at a root with just bright field. It's pretty bland. You can see all the root hairs and stuff on the side of it, but
you can't see the colonization because
can't really, unless you find a really thin part, which we're going down to the end, and nope. Sometimes I've managed to be able to get somewhat of an image. Like you can kind of see through the bottom over here, but yeah, like even if we go brighter light, it's starting to get washed out, and you can kind of see through it. But yeah, what we can do and test and see with the epifluorescent light is pretty,
yeah,
we're at help people see things.
Yep, and we're at pretty much an hour, so I just want to thank you for coming on, Matt, and giving us a really cool tour of the understanding of how
I did have one other. I got a couple more minutes here, and I did want to switch over to. Did have one image of what I wanted to mention about water. So yeah, here's right here is right next to my road. Is where it crosses the road. So like, you can imagine, you got one property and then another property and another property. So one property, their road washes out. So they build a bigger culvert. And then, I have to then build a bigger culvert to keep up with all the water that comes on down. And it's all one big system. And the main thing is like this stone, I actually need to raise it up a couple of inches. But I put this because all behind, back behind where that stone is a big wetland. So that's where all the water can store. So when there is a flood, that can blow up to like a mini lake and hold so much water, which then makes it so there's not so much running down in the system.
Right.
And it's about slowing down the water and yeah, holding it on the property, and well as knowing where when it does flood, where is it going to go, and having a nice spot for where it can just kind of spread out and then soak
Sink.
into the groundwater.
Yeah, it sinks down, filters, and goes back into the aquifer. I mean, that's why beavers were man's best friend until we killed them all.
Yeah. But yeah, so then it was basically the story I had where here's right at the bottom here there's a small pipe going across, and I got neighbors to the right, and like a decade ago I had some nasty neighbors, and they basically decided that all their we were putting all our water onto their property, and they're lower than us, so they decided to cement up this the pipe that runs across right here. And let's see, what was the other picture I had? So you can see this is where the water came down the property, the blue line, and then right there is where it crossed through a little stream. So they cemented that up. This black box down there is their house. So and I offered to help clear his culvert stream and get the water flowing so it didn't flood his backyard. And nope, he wasn't interested in that, just wanted to cement it up. So where does the water go? You can see the contour lines, and it went all right down here under the house, undermined this corner of his house, and filled his front yard with water.
Idiot.
So it's just the water is going to go where it needs to go.
Yep.
And it's
Some
such
people.
a funny thing. I've always loved just watching the water and how it flows over the land, and how we can manage it better with like having this whole little wetlands area here that can fill up with water. Just a little bit buffer before it goes across, and then on and down into the river.
Yep. Berms and swales.
Yep.
But yeah, so I'm just about out of time, and I got to run, but just wanted to squeeze that in there.
Thank you, Matt.
Thank you, Matt. Much appreciated, my friend. And definitely check back in with us, like, not in the dead of summer, but like the cuspid between spring and summer, where things are just blowing up, exploding in growth. Because it'd be really cool to get some wetland as well as some
wetlands.
Yeah.
Maybe one of these days I'll find a tardigrade.
Yeah. One of these days we're going to find one, dude.
Yeah, one of these days. I'll find one eventually.
All right. Well, Ken, thank you so much for your time, Matt. Really appreciate it. Ken, as always, pleasure, my friend, for putting this together, making it happen every week. And other than that, you might as well go ahead and make your final announcements or your house cleaning.
Okay, guys, tomorrow we have vortexes. So if you've ever wondered what vortex energy is, we've got a gentleman coming on with me tomorrow that has been on the History Network talking about vortexes. So that's going to be really an exciting show tomorrow. And I'm going to get him on with Leighton as well, because that'd be a whole different conversation. So guys, stay tuned. We got, of course, Andy Lopez and myself on Wednesday as well. But other than that, next week, we've got Wiggle Brew coming on with Leighton as well. Leighton, you're going to really be excited on how they're stabilizing their liquid so that it doesn't explode in transport. But you'll have to ask Sam next week on how they're doing that.
Nice. Looking forward to it.
Hey guys, peace out. Sorry for the short show, but Matt had other things to do. So we'll see you guys tomorrow. Leighton, love you, brother. We'll talk to you soon.
Back at you.